All right, exam 3, problem 2. What we have here is a fairly standard setup to demonstrate atmospheric pressure, and normally this would be mercury. We're going to do one example with mercury. We're going to also do water and ethyl alcohol. The point is there's vacuum here, and because there's a vacuum at the top, there's no pressure on the top here, right? Because there's vacuum in this tube, which means the pressure down here is atmospheric pressure. Well, all of this column has to come up to equal atmospheric pressure. So the question is, what's the pressure of the column, right? Well, the pressure of the column is just the density times acceleration of gravity times the height, right? So let's go with part A. The question is, how high into the evacuated column will each of the following fluids rise? So how high will water go? If we solve for height, right? Height is pressure divided by density and gravity, so the acceleration of gravity. All right? Height is P over rho G. So what is this for water? Now we have height equals, all right, so 1.01 times 10 to the 5th pascals is what we're looking at in terms of pressure on top. Density, 1 times 10 to the 3rd kilograms per cubic meter, right? And our acceleration of gravity, 9.8 meters per second squared. Right? All right. So 1 times 10 to the 5th pascals divided by 1 times 10 to the 3rd kilograms per cubic meter times 9.8 meters per second squared. All right? All right, what do we get? We have 1.01 E5. Well, 1.01, let me do this, 1.01 E5. All right, that's atmospheric pressure. 1 E3, that's the density, 9.8. All right, so the height is the pressure divided by the density divided by acceleration of gravity. So 10.3. All right, 10.3. And in this case, 10.3 meters. All right? All right, so for water, 10.3 meters. Part B. Okay. Part B, everything is pretty much the same except what? Our density is now 13.6. 13.6 times 10 to the 3rd kilograms per cubic meter. All right? And what does that mean our answer comes out to be? Well, if we go over here to Excel, I'm just going to go here. I'm going to change this to 13.6 E3, right? And now we get 0.758 meters, right? 0.758 meters, or 758 millimeters of mercury. All right, so another way to put that. All right, now part C. How high would the ethyl alcohol go at 0.79 times 10 to the 10 to the 3rd in density? So let's grab that. 0.79 here, right? 0.79 times 10 to the 3rd. And if I change this to 0.79 E3, we get 13 meters, right? 13 meters. So the ethyl alcohol will go up 13 meters, the water 10.3 meters, and the mercury just 0.758 meters. And that's it for problem 2.